Hello students, welcome back to another class of mathematics for PUC second year students, class 12th students. And today's topic is derivatives. In derivatives, we have already seen derivatives in earlier videos, earlier videos. I have explained how to differentiate given function. We have discussed and we learned some formulas also. I have still written some formulas here. You can note down the formulas and learn them, memorize them. These are very useful formulas in derivatives, right? Now, today's topic is second order derivatives. In this chapter derivatives, we will see second order derivatives. Second order derivative. We have to find second order derivative. Second order derivative means we have to differentiate the given function two times. Differentiate once, that will be first order derivative. Then to that first order derivative, if we differentiate again, that becomes second order derivative. That gives second order derivative. So questions are given. I have written some questions from exercise 5.7 in your reader. Find the second order derivative. This is the main question. Question number 1, x square plus 3x plus 2. Question number 2, x to the power of 20. Question number 3, x into cos x. Right? Now the question number 1 is x square plus 3x plus 2. We have to find second order derivative of this. So whatever function is given, write that function as y is equal to, or you can also write f of x is equal to y is equal to x square plus 3x plus 2. This is the given function. I have taken y. You can denote the given function with, you can write it as f of x also, right? Okay, now differentiate with respect to x. Differentiate with respect to x. To differentiate this with respect to, when we differentiate, y becomes dy by dx. That means differentiation of y with respect to x will be, we have three terms here separated by plus sign, so we can differentiate them separately. We will differentiate x square plus, then we will differentiate 3x, then plus we will differentiate 2, right? Because they are separated by plus. When plus or minus terms are separated by plus or minus sign, you can differentiate them separately. But if there is multiplication, we have to apply product rule. When there is division sign, we have to apply quotient rule, that we will discuss. Now, x square, differentiate x square is same as x raised to n. X raised to n, x to the power of some number. What happens in this case? This n must multiply here, and we have to make one less in the power, right? Power will multiply with the coefficient and power will be decreased by 1. So to differentiate x square, this is n is 2 here, so this 2 will multiply here, it will not have any coefficient, so 2 x to the power of, x will be like this, 2 will, the power will decrease by 1, 2 minus 1, right? So can I directly write as 1 here? Yes, 2 minus 1 is 1. But when power is 1, no need to write, right? Plus 3x. 3 constant as it is. In my previous video also I showed you, when there is a constant multiplied to a function, that constant is kept as it is and just differentiate the function. What is the differentiation of x with respect to x? Differentiation of x with respect to x will be always 1. It is dx by dx, right? It will be 1. So differentiation of x with respect to x is 1. 3 constant as it is, because 3 is multiplied to x, and then differentiation of x is 1. Plus, what is the differentiation of 2? 2 is a constant. 2 is a constant. What is the differentiation of constant? Differentiation of constant is always 0. When there is no x term, when there is no function, only constant is there, it will become 0. Now you may be thinking that, sir, why this 3 did not become 0? Because there is x with it. We cannot make this as 0. When there is function with the constant, the constant is kept as it is and differentiation of function is done. Right? It is differentiated. But when constant is alone, there is no function with it, there is no x term with it, there is no x with it, then that becomes 0. Differentiation of constant is with respect to x is 0. So 2 becomes 0. So that becomes dy by dx is equal to 2x plus 3. 2x plus 3. This is first order derivative. This is first order derivative. We have to find second order derivative. It means we have to differentiate this once again. Differentiate again with respect to x. Differentiate this again with respect to x. So dy by dx, when we differentiate again with respect to x, it becomes d square y by dx square. D square y by dx square, or d2y by dx square. Some people read it. It is also read as d2y by dx square or d square y by dx square. Second order derivative will be equal to, differentiate this again. Now 2 is multiplied to x. When constant is multiplied to function, that constant is kept as it is, and we have to differentiate the function. So x, differentiation of x is 1. Differentiation of x with respect to x is 1. So plus, then 3. Differentiation of 3. 3 is a constant again. So differentiation will become 0. Right? So d square y by dx square is equal to 2 into 1 is 2 plus 0. 2 plus 0 is 2. So this is the final answer. Right? Second order derivative. This is the first order derivative. To that first order derivative, we differentiate again, we get second order derivative. Like for example, here we have question number 2. Question number 2 is, let's say y is equal to x to the power of 20. Given function we have taken y is equal to, or you can take f of x is equal to also. Differentiate it. Differentiate with respect to x. So it becomes dy by dx is equal to dy by dx is equal to, this is same as x raised to n. X raised to n. X raised to n. What is the differentiation of x raised to n? N must multiply here, right? And we have to decrease the power by 1. So what will happen? This 20 will multiply here. This 20 will multiply with the coefficient. Coefficient is 1. 20. It becomes x to the power of 20 minus 1. 20 minus 1. N minus 1. N becomes n minus 1. So 20 will become 20 minus 1 is 19. This is the first order derivative. Now second order derivative. First order derivative is over. No more simplification is possible. Now second order derivative. To get the second order derivative, we have to differentiate this again. Differentiate again with respect to x. So dy by dx becomes d2y by dx square. Dy by dx becomes d2y by dx square. So that becomes, now differentiate this again. 20 constant will be as it is. When constant is multiplied to any x, then it is kept as it is. So 20 as it is. Differentiate x raised to 19. X raised to 19 is again same as x raised to n. X to the power of 19 is same as x to the power of n. So it becomes n 19 x to the power of 19 minus 1, that is 18. Now these 2y by dx square will become 19 into 20, that is 19 zeros are 0, 19 twos are 38, that is 380, x to the power of 18 as it is. So this is second order derivative. Second order derivative. Now let's see the next question. Question number 3. What is question number 3? Question number 3 is, two different functions are there, x and cos x. They are in product. They are in multiplication. When two functions are in multiplication, when two functions are in product, we have to use product rule. Product rule is used. Product rule. I showed you in my previous video product rule. What is the formula of product rule? I will write down once here. The formula of product rule is, if there are two functions u and b, two functions are in product, then the differentiation will be equal to u as it is, first function as it is, differentiation of second plus second function as it is, then differentiation of first. This is the product rule. When two functions are in product, they are in multiplication. So we have that type of question here. Two different functions are there. X is one and cos x is another. They are in product, right? So we take this as y is equal to x cos x, right? X is u and cos x is v. uv formula, right? This is u, this is v. So differentiate with respect to x. Don't forget that we have to differentiate two times, second order derivative. So first we will differentiate once, then again we will differentiate, right? So this becomes dy by dx will be equal to, according to the UV product rule, UV rule or product rule, first function must be as it is. So first function is x here and second function is cos x. So x as it is, first function as it is, differentiation of second function is cos x, differentiation of cos x is minus sin x, differentiation of cos x is minus sin x. So differentiation will be minus sin x. First function as it is, derivative of second. We differentiated the second, cos x, differentiation is minus sin x. They will be in product. See here, u and dv by dx. They are in product, right? U and dv by dx is over. Plus b as it is. B means second function as it is. Second function is cos x here. Second function is as it is into b into differentiation of first. Differentiation of u. Differentiation of u. What is u here? X. What is the differentiation of x with respect to x? It is 1. So it is as it is. So what we got? We got dy by dx as minus, this will be plus into minus is minus, x sin x plus cos x into 1 is cos x. This is first order derivative. First order derivative is over. Now we have to differentiate this again. Second order derivative. To get the second order derivative, differentiate again with respect to x. Differentiate again with respect to x. So when we differentiate dy by dx again with respect to x, it becomes d2y by dx square. So that will be equal to, keep this minus sign as it is. It will be applicable to all the terms when we differentiate this, right? Because this is applicable to this. So when we differentiate this, this minus sign will be applicable to them, right? But here again we are having uv. We have again here u into v. Two functions are in product. X into sin x. X into, again we have to apply uv rule here. uv rule. What about this cos x? Plus sign is there. So we will differentiate it separately. Plus we will differentiate this. But to differentiate this one, we have to apply uv rule, right? So first function as it is, u as it is, differentiation of v sin x, differentiation of sin x is cos x. Differentiation of sin x with respect to x is cos x, right? U as it is, x as it is, sin x differentiation is cos x. Plus u dv by dx. U dv by dx is over. Plus second function as it is. Second function is sin x here. Sin x as it is into differentiation of first. Differentiation of u, first function. What is first function here? X. What is the differentiation of x? 1. U dv by dx plus v du by dx is over, right? Then plus this plus sign, differentiation of cos x. Differentiation of cos x is minus sin x. Differentiation of cos x is minus sin x. So differentiation of cos x is also over, right? It has only cos x. Now that will be, let's simplify and see what happens. That becomes, if you multiply by minus sign, this minus into plus will become minus x cos x, then this minus into plus will become minus, sin x into 1 is sin x, plus into minus becomes minus sin x as it is, right? Now, so that becomes d square y by dx square is equal to minus x cos x as it is, minus 1 sin x minus 1 sin x becomes minus 2 sin x, right? some more simplification. If you want to do more simplification, you can just take minus common. One more step is possible. Just take minus common, it becomes x cos x plus 2 sin x. This we can do, or you can leave here. That is also correct answer. This is the second order derivative. I hope you all understood these questions. Let's solve some other problems. So the next problem is, we have two more problems in the same exercise, 5.7 in your reader. The next question is question number 4, that is log x. We have to find the second order derivative of log x, and the fifth question is x cube log x. Let's start with this question, that is log x. Take the given function as, suppose I take f of x. You can take y is equal to, no problem. You can take y is equal to, or you can take f of x is equal to, no problem. Then differentiate this with respect to x. Differentiate with respect to x. When we differentiate f of x, we must write f dash of x. What does f dash of x mean? The first order derivative of f of x is f dash of x, right? y ना तो उसके डिफरेंशिएशन को हम dy by dx लिख सकते हैं, y के डिफरेंशिएशन को dy by dx लिख सकते हैं, या y के डिफरेंशिएशन को हम y dash भी लिख सकते हैं, ये y को डिफरेंशिएट करें तो हम उसको y1 भी लिख सकते हैं, y को dy by dx को डिफरेंशिएट करने के बाद या उसको y dash लिख सकते हैं, या f of x को क्या लिखना, डिफरेंशिएट करें तो f dash of x लिखना, f dash of x, ये f dash of x f of x का डिफरेंशिएशन होने से f of x का डिफरेंशिएशन f dash of x. log x को डिफरेंशिएट करना है, log x, what is the differentiation of log x? log x का डिफरेंशिएशन हम देखिए, log x का डिफरेंशिएशन है 1 by x, log x का डिफरेंशिएशन है 1 by x. तो डिफरेंशिएट कर दिए इसको, सिंप्लीफिकेशन पॉसिबल नहीं है, कुछ भी सिंप्लीफाई नहीं कर सकते. ये हो गया फर्स्ट ऑर्डर डेरिवेटिव, फर्स्ट ऑर्डर. लेकिन हमको होना है सेकंड ऑर्डर डेरिवेटिव. क्वेश्चन में है फाइंड द सेकंड ऑर्डर डेरिवेटिव. तो सेकंड ऑर्डर डेरिवेटिव के लिए डिफरेंशिएट अगेन डिफरेंशिएट विद रिस्पेक्ट टू x. फिर से डिफरेंशिएट करना, f डबल डैश ऑफ x हो जाता है, f डैश ऑफ x जाके f डबल डैश ऑफ x हो जाता है. डबल डैश, सिंगल डैश का मतलब फर्स्ट ऑर्डर डेरिवेटिव, डबल डैश का मीनिंग है सेकंड ऑर्डर डेरिवेटिव. सो f डैश ऑफ x हो गया f डबल डैश ऑफ इज इक्वल टू 1 by x. इसका डिफरेंशिएशन करना है. 1 by x के डिफरेंशिएशन के लिए एक फार्मूला लिखना मैं भूल गया, वो फार्मूला है डिफरेंशिएशन ऑफ 1 by x raised to n with respect to x. इसका डिफरेंशिएशन कैसे करना है, ये प्रीवियस वीडियो में भी हम डिस्कस करे सो है. 1 by x raised to n, या फिर ऊपर कुछ भी कांस्टेंट आया तो भी चलता है, कोई भी कांस्टेंट डिवाइडेड बाय x raised to n. कांस्टेंट, ऊपर कांस्टेंट है और नीचे x के पावर में कुछ भी नंबर रहा तो इसके डिफरेंशिएशन के लिए क्या करना, साइन चेंज करना है. अगर ये पॉजिटिव है तो नेगेटिव कर देना, अगर ये नेगेटिव है तो पॉजिटिव करना. साइन चेंज हो जाता है, साइन हो गया नेगेटिव. फिर ये पावर को ये न्यूमरेटर से मल्टीप्लाई करना, पावर को न्यूमरेटर से मल्टीप्लाई करना, n into k, n k हो जाता है ना, n into k डिवाइडेड बाय नेक्स्ट डिनोमिनेटर में x के पावर में एक ऐड करना. 1 is added to the power. जैसा इसमें पावर में एक डिक्रीज करते हैं, यहाँ डिनोमिनेटर में पावर में एक इंक्रीज करना. दिस इज द मेथड टू, डायरेक्ट मेथड टू फाइंड दिस डेरिवेटिव ऑफ एनी कांस्टेंट डिवाइडेड बाय x raised to n. एनी कांस्टेंट डिवाइडेड बाय x raised to n, राइट. तो यहाँ कांस्टेंट है 1, कांस्टेंट है तो हम ये रूल अप्लाई कर सकते हैं. अगर ऊपर कांस्टेंट है ना, ऊपर भी फंक्शन रहा तो, ऊपर भी फंक्शन नीचे भी फंक्शन रहा तो u by v रूल यूज होता है. वो u by v रूल जब आएगा तो हम फिर देखेंगे, प्रीवियस वीडियो में भी हम डिस्कस करेंगे. तो हम क्या करना है, इसको डिफरेंशिएट करने के वास्ते साइन चेंज करना. साइन चेंज हो गया, फिर x के पावर में यहाँ 1 है, वो 1 और ये 1 मल्टीप्लाई हो गया, 1 1 1 डिवाइड बाय, फिर x के पावर में एक ऐड करना, 1 + 1 हो गया 2, राइट. तो सेकंड ऑर्डर डेरिवेटिव आ गया -1 by x². मोर सिंप्लीफिकेशन पॉसिबल नहीं है, तो यही इसका आंसर है. अभी देखेंगे थर्ड, नेक्स्ट क्वेश्चन. So the next question is x cube log x. Fifth question, x cube log x, x cube log x. Now we have to differentiate this. Take this as y is equal to x cube log x, x cube log x, right? Now, differentiate this with respect to x, that will give us the first order derivative. Differentiate again, that will give the second order derivative. Right, so differentiate it, again this is in product rule, right? Two different functions are in product, two different functions are in multiplication, right? This is the product of two functions, so we have to use UV rule again. What is the UV rule? Differentiation of u into v will be u as it is, differentiation of v, u लिखना पहला फर्स्ट टर्म एज इट इज लिखना, सेकंड को डिफरेंशिएट करना, प्लस फिर सेकंड टर्म एज इट इज लिखना, जैसे वैसा लिखना, फर्स्ट टर्म इज रिटन एज इट इज, differentiate the first one, right? This is uv rule. So uv, so differentiate, let's write y1 for differentiation. You can write u by dx, you can write y1, you can write y dash also. Differentiate, we are differentiating actually for, right, differentiate with respect to x here once. Okay, so that will give you first function as it is, u as it is, first function as it is, u as it is, differentiation of second. What is the differentiation of log x? Differentiation of log x is 1 by x. Differentiation of log x is 1 by x. First function as it is, differentiation of second, plus second function as it is, differentiation of first. Second function as it is into differentiation of first, x cube का differentiation 3x square, x cube का differentiation 3x square. Why? Because ये x raised to n जैसा है, 3 इधर मल्टीप्लाई हो गया, 3 कोएफिशिएंट में मल्टीप्लाई हो गया, 3 1 3 1 है, फिर पावर में डिक्रीज कर दी, 3 में कम कर दिए तो 2 हो गया, 3 में डिक्रीज कर दिए तो x raised to n जैसा है ना, x raised to n, x cube x raised to n जैसा है, right? So first function as it is, differentiation of second, plus second function as it is, differentiation of first is over. Now simplification is possible, so y1 is equal to some simplification. Here these two will get cancelled and 2x's will be left. Here we have x cube, 3x's are there, so 1 will get cancelled, 2x will be left, 2x are left, plus 3 constant as it is, 3 constant, I will write to 3, then x square log x, log x into x square is x square log x. We got this, right? This is first order derivative. Now we have to get second order derivative, so differentiate again differentiate with respect to x, again differentiate with respect to x, second order derivative, right? So y1 can be written as y2, y1 becomes y2, second order derivative will be equal to, now differentiate this, so we'll first differentiate this term, then plus you can differentiate this term, right? So differentiation of this term, this is same as x raised to n, this is same as x raised to n, so n will multiply in the coefficient, 2 will multiply in the coefficient, and x to the power of 2 will decrease by 1, 2 minus 1 is 1, so when power is 1 no need to write, plus, now this one, to differentiate this, 3, I told you, constant when multiplied to function, keep the constant as it is, and then differentiate this. To differentiate this too, you have to again use UV rule, U into V, product rule, right? First, why I am using this bracket? Because 3 is multiplied to these two, so when I differentiate these two, 3 will multiply to all terms, right? So use bracket. Then first function as it is, U as it is, differentiation of V, differentiation of log x is 1 by x, plus log x as it is, second function as it is, differentiation of first, x square का differentiation हो जाता 2x. How? We have already seen, no need to explain again and again, right? Now this one, first function as it is, derivative of second, plus second function as it is, differentiation of first is over, u. So now we will simplify, y2 is equal to this 2x as it is, nothing can be done here. Here we can cancel, 2x are there, 1x will get cancelled, plus now 3 into x is 3x, plus 3 will multiply to this also, here we have 2, so 3 2s are 6, this log x into x becomes x log x. This is second order derivative, more some further simplification is not possible, so this is the answer. Or sorry, we can do one thing, Simplification is possible. Simplification is possible. That is why 2 is equal to 2x plus 3x becomes 5x plus 6x log x, right? Or some more simplification is you can take x common here. If you take x common here, 5 is left plus 6x log x is common, so 6 log x is remaining. So this one is the final answer. More simplification is not possible, right? So this is the answer. Second order derivative of x cube log x. I hope you all understood these problems. I want you to practice, and if you have any doubt you can write in comment. I will try to clear. Thank you for watching.